So this assignment is related to the particle physics and accelerators. It's having two parts. One is the MCQs. The MCQs, multiple choice questions, I will share with you as a weekly homework this week. The structure questions, the first 11 we did. So we'll start with question 12. In question 12, the wavelength associated with the moving particle known as the de Broglie's wavelength, which depends on the momentum of the particle, show that the momentum and kinetic energies are related by equation Ek is equals to P square over 2m. So it's a short derivation in which you have to derive this relation that the Ek is equals to P square over 2m means kinetic energy is a momentum square divided by twice the mass. So if we write equation of kinetic energy, what is the equation for kinetic energy? Kinetic energy Ek is equals to half mv square. Now, if I multiply and divide, like if I multiply this equation by m, both sides, so I can say m into Ek is equals to m square v square over 2. So, or I can say Ek, m into Ek. What is m square v square? It's a momentum square because momentum is mv. So if it is m square v square, it means it's a momentum square. So I can say momentum square over 2. If I need Ek, Ek will be equals to P square divided by 2 is already there m. So this is a formula which we derive that the kinetic energy is momentum square divided by 2m. The de Broglie's determine the de Broglie wavelength for a proton with a kinetic energy of 18.8 kilo electron volt. Whenever you substitute the values, it should always be in joules in the formula because SI unit is joules. So Ek is equals to P square over 2m. We need the de Broglie's wavelength. What is the formula for de Broglie's wavelength? That is lambda is equals to h over p. It is h over mb or h over p. So means from this formula, first we have to work out p. So 2m will be multiplied into Ek and then we'll take a root. This will give us a value for p. And after getting the value for p, the de Broglie's wavelength lambda is equals to h over p. The kinetic energy, it's given in kilo electron volt. So we have to convert into joules. So if it is 18.8 kilo electron volt, kilo means 10 power 3. So it will be 18.8 into 10 power 3 electron volt. And to convert electron volt into joules, we have to multiply by 1.6 exponent minus 19. So it will be 18.8 into 10 power 3 multiplied by 1.6 into 10 power minus 19. This will give us the energy in joules. So when we multiply, this will be 3.01 into 10 power minus 15 joules. So we have the energy in joules. So 2 multiplied by mass. This is for proton. So what is the mass of proton? This will be given 1.6 into 10 power minus 27 kilogram. The kinetic energy, we work out 3.01 into 10 power minus 15 and we'll take a root. That will give us a momentum which will be in kilogram meter per second. The momentum of this particle on Newton second, you can also write 6.63 into 10 power minus 21. After getting a momentum, the de Broglie's wavelength h, the constant value of h is 6.63 into 10 power minus 34 divided by the momentum, that is the momentum we work out 3.17. The momentum here is 3.17 into 10 to the power minus 21. So we substitute 3.17 into 10 to the power minus 21. That will give us a wavelength, the de Broglie's wavelength 2.01 or 2.09 into 10 to the power minus 13, and the unit will be meters. Is it clear, this one? The de Broglie's wavelength? In question 13, in 2015, scientists at CERN announced that discovery of a particle known as a pentaquark. At this time, the quark structure had not been determined. It was suggested that it might be 5 quarks tightly bonded at a single particle or a meson-baryon molecule. The diagram illustrates the single particle with the 5 quarks. The table shows the charge. Complete the following diagram to show how the 5 quarks shown in the single particle model could be arranged in a meson-baryon molecule. You should have charge 0 and baryon, like the meson should have a charge 0 and the quark should have a charge of plus C, means like +1, like same as the charge of electron. So first thing, charge 0, the charges are shown. Like what will the charge of up? It is 2 by 3. So this will be 2 by 3. NT, this will be minus 2 by 3 NT charge. Up will be 2 by 3. Down will be minus 1 by 3. And charge will be 2 by 3. These are the charges. And we need like meson, which is contains quark and anti-quark. So this should be here. But why I will not write C. Reason is that because an identical antiparticle will annihilate and they instantly convert into energy. So that does not support the structure. So that's why I cannot put anti-charm and charm together. Instantly it will annihilate. I want a net charge for a meson to be 0. So if it is minus 2 by 3, I want a particle which is plus 2 by 3. So which particle is plus 2 by? So I have two options, either up or charm, but I cannot put a charm because it will annihilate. So I will put up. So it will be plus 2 by 3 and minus 2 by 3. So the net charge will be 0 on the meson. And then what we are left, we use this and this. So we are left with up, C and down, charm and down. And what will the net charge on this? You can calculate, like up is plus 2 by 3, down is 1 by 3, and charm is down is minus 1 by 3, and this will be 2 by 3. So when you add, you will get as the net charge of same as the electron or plus E. Pentaquark has a mass of 4.38 giga electron volt converted into kilogram. So how to convert into kilogram? As I mentioned, if you write up, up and down, what will be the problem? Look, for example, if you write up, up and down here, because you have the combination. If you write up, up and down, then what you're left with? You're left with charm and anti-charm. Charm and anti-charm cannot, in a baryon, if you write up, up and down, means you're left with charm and anti-charm. So it means they will annihilate. So this meson will not even exist. Meson means quark and anti-quark, but it is not like particle and it's the same anti-particle. Like a meson cannot be up and anti-up. No, it will instantly annihilate. So this meson does not exist. Meson exists when one antiparticle of one quark combined with particle of another. So if I write up and down, I will not get a correct meson. That's why the second combination is not acceptable. Then we have to convert how this mass is there. So how much energy it will produce? It will produce 4.38 giga electron volt. That is the same amount. So first we convert. Now we need the mass. So E is equals to mc square. If I need the mass, it will be energy divided by speed of light square. So energy, but energy should be in joules. This will be 3 into 10 power. So giga electron volt, like I have 5.38. Giga means 10 power 9. Electron volt, then electron volt into joules. So it will be 4.38 into 10 power 9 multiplied by 1.6 into 10 power minus 19. So we multiply 4.38 into 10 power 9 multiplied by 1.6 into 10 power minus 19. When we multiply this and divide it by speed of a light square, we'll get the mass, and that mass will be in kilogram, kg, which is 7.8 into 10 power minus 27. So whenever you find the mass in kilogram, remember, convert the energy giga electron volt or mega electron volt into joules. In part C, the pentaquark was produced in the decay of a lambda 0 particle, which was created after a collision between a high energy protons. In the experiment CERN, a lambda 0 particle was determined to have a travel at a distance, travel 9.3 centimeter after the creation before a decay. The lambda 0 particle exists for 1.48. Use these results to calculate the value of a speed and comment on your answer. So speed is distance divided by time, because we assume it does not accelerate. So it is in centimeter, we have to convert into meter. So 3.9 divided by 100 to convert into meter, and then the time 1.48 into 10 power minus 12. When we divide, this will give us a speed which is 2.64 into 10 power 10 meter per second. So if you see, this is speed. And what about the speed of a light? The speed of a light is 3 into 10 power 8 meter per second. And what is the relativistic effect? Relativistic effect is that whenever particles move closer to speed of a light, their mass does not remain constant, their mass increases. So when we compare with the speed of a light, the speed, and we say nothing travels faster than speed of light. No particle, nothing travels, like light is the fastest thing. Nothing travels faster than speed of the light. So here, when we calculate these values, we are getting a very high, like greater than the speed of a light. So it means this is impossible, or a relativistic effect may apply here, that this particle mass will increase, so it cannot travel closer, like the higher than the speed of a light. Because what actually happened when the particles are produced, or particles are moving, if they, when they travel closer to speed of a light, their mass does not remain constant. The mass start to increase, and we call that as a relativistic effect. Like if electron, mass of electron is 9.11 exponent minus 31, that is called a rest mass. But if the electron is moving closer to speed of a light, its mass start to increase. So here, when we calculate the speed of this particle, it comes out greater than the speed of a light, which is impossible, because what will happen when it approaches closer to speed of a light, this particle mass will start to increase, so its speed start to decrease. The experiment at CERN involved a colliding proton. Why a high energy is needed? for this experiment. So why we need a high energy to collide the two particles with each other, an identical particle? First thing, two protons, they will have the identical charge. And what do like charges do? Like charges will repel each other. So they have a strong electrostatic force. So first thing, why we need a high energy? We want to overcome the strong electrostatic force of repulsion. So they can collide with each other. Another thing, because if you see the particle which we are producing here is a pentaquark. Pentaquark means like five quarks. Five quarks are there, a combination of a five quarks we want to produce. So to produce a high mass, as I mentioned, if we want to produce a high mass, what we need a high energy. So because the mass energy is conserved, we don't say mass is conserved or energy is conserved. We say the total mass energy is always conserved in the collision. So as we want to produce a large mass, so we need a high energy. And another thing, because protons are having a light charge and light charge repel each other. So to overcome the electrostatic repulsion, that's why we have to collide them at a very high speeds. So 2 points are for electrostatic repulsion. Like 1 mark, protons are identical, carry a same charge. So electrostatic repulsion. That's why we need a high energy to overcome that. Another thing, when these protons will collide with each other, they will release energy or energy will be released. That energy is actually producing a matter. So because we need more matter, so that's why we need a very high energy as well, as the mass energy is conserved. So this was question 13 from particle physics. Any question or doubt related to the session?